How are inequalities different than equations like we just solved? What's going to be different about them? For example, if I gave you this, if I asked you that, how would you graph it?
That inequality is something.
And then that's how we graph it. And then, okay, so when we graph it, what all do we get? So my x-intercepts are where? Okay. So we know that's the function also. So it's going to be x plus 3. What kind of function is it? What's the basic shape of this function? Remember, how do we determine the shape of the function?
Domain.
What determines the shape of the function? Ah, very good. You're saved. So what's the degree of this polynomial? How do we know that? What are these numbers called? Very good. They're called multiplicities. Multiplicities are the degrees, are the exponents of the factored form. What good do they do for us? What benefit do they show us?
The multiplicities. Because whether the graph crosses or bounces off
Right.
the x-axis.
So at -3, what happens? At 1, what happens? You just told me what happens.
Oh yeah, crosses. Oh, bounce. Yeah.
So since it's a third degree equation, what does it look like? What's the end behavior? Opposite directions. Is it increasing or decreasing? Right, because all the x's are positive. So that means from this end it goes up, from this end it goes down. Since this is an odd degree, I cross it. Since this is an even one, I bounce. What's my y-intercept? How do you find the y-intercept? Set x equal to 0. If you set x equal to 0, what do you have left? What does that equal? -1 squared is +1 times 3. So we know it crosses at 3. Okay, so now we graphed it, but have we answered the question yet? Where is this question is asking us, where is this function greater than, strictly greater than 0? What does that mean about our picture? What part of the picture are we looking at? What's that? Because here we don't wait with y. It's just all it's saying, if it's greater than 0, that means the answers are all what? Positive. That means they're all above the x-axis. So where is this graph above the x-axis?
The first quadrant. And the.
Give me intervals.
oh,
Intervals.
Yeah.
Negative, open or close parenthesis, or parentheses or brackets.
Oh, where else? I think the homework is.
No, because there's no equal sign here, it cannot equal 0. So it cannot be the intercept. So it has to be parentheses. And then where else?
1 infinity.
And it's union. I think the computer is going to ask for this. They'll ask you for a comma, but it's supposed to be union because your answer is actually any value here or here. And that's what that symbol there means.
Would it also be a bracket because at the point of -3, you don't know whether it's going.
No, because it cannot equal 0. At -3, it equals 0.
I think the homework's screwed up though. I think it'll tell you to put a bracket in there.
Really?
Yeah.
Okay, well, let me apologize for the online homework. You know who puts the answers in there? Well, the publisher does, but you know where they get the answers from? They get a bunch of the authors, the publishers print out thousands of these questions and just give them to college students and pay them something like $5 a sheet to answer. Nobody ever checks them. And that's what goes in as their answer key. So you guys will find answers that are wrong. Ooh, here's one. And I apologize for that. X to the 4th is bigger than X. Solve that for me. To solve polynomial inequalities, here are the steps. First step, what do you think the first step is going to be? Set it equal to 0. The reason you have to set it equal to 0, because we're only going to look for where is it above or below the x-axis, or equal to the x-axis. But since this is a strict inequality, it's not going to equal the x-axis, the intercepts. So our first step is to move the x.
Oh, okay.
Second step, factor. So what can I factor out of here?
X.
Which leaves me x cubed minus 1. Now what? Find the x-intercepts. How do we do that? Set these two equal to 0. So we have x equals 0 is one of them. Then x equals 1. So far, so good. Plot on a graph. Actually, we don't need a graph, but it just makes it look nicer. All we need is the x-intercept, because all we're going to care about is where the y x values will give me a positive answer or a negative answer. I said, are they open or closed circles at those points? Because there's no equal sign, they're both open circles. So now we gotta look at these values, and these values. Which ones will give you this solution? So if we put in -1, 1/2, and 2 in there, what happens? If we put in -1 into this equation, what do we get? -1 to the 4th is what? 1 minus a -1.
Not greater
No. -1 to the 4th minus -1. This is 1.
than 0. Oh,
Negative is a positive.
oh, it'd be 1. It's greater than 0. Not
2. 1 plus 1. That's okay. He's gone. So you,
Is that a STEM scout?
no, he was my boss. We have to do evaluations.
I was feeling nervous. I was like,
So, so, so it's 2 is greater. So this is positive. So this is up here. So this interval works. How about at 1/2? If I have 1/2 to the 4th minus 1/2, is that greater than 0? What is 1/2 to the 4th? More, nope. 2 to the 4th power is 16. Minus 1/2. So this number is bigger than this one. So this one's going to be in the negative realm. So this one's not going to work. 1/16 minus 1/2 is going to be a negative number. How about at 2? So we have 2 to the 4th minus 2. 16 minus 2 is greater than, so it's 14 is greater than 0. So my answers are from -infinity to 0, from 1 to infinity. Now, the computer can ask you different ways of putting this stuff. For example, this one, it can ask you saying that x such that -3 is less than x is less than 1, or x such that x is greater than 1. You have to be able to put it both ways, in the interval notation and in set notation.
I think it asks you to actually, it gives you the bracket X
This one and the bar,
and then.
this
next
is
to it,
such that.
it's that, and then next to it, you actually have to type in X equals.
Or whatever this is.
-3, 1.
Oh, really? You have to, they want this specifically that? X equals, okay,
Yeah, they ask for the equation.
that's weird. But you, again, I don't know, we don't do that in mathematics, but I don't know how they want the answer to be filled, whatever it is, you have to be able to do it both ways.
Half the battle.
Exactly, yes. And that's, again, that I do apologize, I'm gonna apologize now, because I have had students in some classes, the higher courses, of course, there are a lot more mistakes in the books because nobody checks those. And they'll take tests and their answers are perfectly correct. It's just that you give them no credit and then they failed the test. And then that's when I have to go in there and check it manually and see exactly what's, and then complain to the publishers. Trust me, they get tired of hearing from me. But the alternative is me doing the work, so I better shut up. I don't want to grade by hand. All right. Graph this function. What's my first step?
Set to 0.
Nope. What do we have to do here?
Oh, yeah.
Factor it first. Always factor. So what does the bottom become? It's the difference of two squares. So my x-intercept, my y-intercept, my vertical asymptote, my horizontal asymptote, my oblique asymptote, and then here's the graph. So what's my x-intercept? Yes. So set the numerator equal to 1 or 0. So x minus 1 equals 0. X equals 1. So there's my x-intercept. What's my y-intercept? Set x equals 0. So up here, set x equal to 0. You have -1 over -4. Positive 1/4. There's your y-intercept. Vertical asymptote.
Go back there.
Don't have to. There. There's a factored form. That's why you factor it. Vertical asymptote. Set the denominator equals 0.
-2 and 2.
So at -2 and +2. Vertical asymptote. Vertical asymptote.
I'm confused about the factoring, but I thought before these, you always factor, because I thought before we just said, oh, you just factor just to see if there's something that can be canceled.
And it makes it easier to find out what the intercepts are,
Okay.
or your asymptotes. Because if we left it this way, you could do it, take the
Oh, I
bottom,
see.
set equal to 0.
I wasn't squaring, I wasn't taking the square root.
Oh, that's got 4. Yeah, that's right, you got 4. Horizontal asymptote or oblique asymptote. Look, it's going to be what? Can't be 1/4. Because in the asymptotes, you only look at the leading coefficients, leading terms. So there's more in the bottom than the top. So what does that mean? If I cancel these, what do I have? If I have x over x squared and I cancel those, what do I have? If I can cancel 1x, right? As x goes to 0, x goes to infinity, where does this function go? One over 1 is 1. 1/2 is 1/2. 1/10 is 1/10. So the bigger x becomes, the smaller this number, so it goes to 0. So since there's more in the bottom, it's y equals 0. So this is your horizontal asymptote. So we have no oblique asymptote. Because we have an x-intercept and y-intercept there, we know that this graph will look something like this. Because remember, as it gets closer to the vertical asymptotes, it has to go to positive or negative infinity. So this one's gonna go negative infinity. This one's gonna go to positive infinity. Now, what about these other graphs? Is it gonna be down here? It's gonna be up there, up here, or down here, or what? How do we figure that out? Plug in a point, pick a point at x equals 3. When x equals 3, what do I get? 3 minus 1, 3 plus 2, 3 minus 2. 3 minus 1 is 2, 3 plus 2 is 5, 3 minus 2 is 1. I get positive 2/5. So this half will look like this. At negative 3, I get negative 3 minus 1, negative 3 plus 2, negative 3 minus 2. So it's negative 4 over negative 5, negative 1. Negative 4 over 5. So the answer is negative, so it's down here.
R of X is greater than or equal to 0.
Now we gotta look at where is the graph above the x-axis? Where is R of X greater than and equal to the x-axis? So it's at negative 2 to 2. Can we use the values of negative 2 and 2? No, because they're asymptotes. Union with everything greater than 2, so 2 to infinity. So what purpose does a multiplicity play for us? What does it serve for us in our solving these things? Yeah. It tells us the degree by looking at the multiplicities. It tells us the degree. The degree tells us the shape, the end behavior, how many solutions we're gonna have, whether it bounces or where it crosses. It tells us a lot, actually. It really helps us fill in the rest of the graph. Any questions? What do you think so far? Did I go too fast? Or is this just bring back bad memories from algebra?
I just gotta like look over it again, you know?
Exactly.
Takes a little while, but.
Well, no, if there's some parts that you don't remember, tell me and I'll refresh it here. I'll do the whole lecture for you.
Thinking that. The college out, of course, I did here, we didn't even bother with any of the graphing, we just did the brackets. Or just doing like a line graph.
Oh, it's like we call it the number line,
Yeah, we just did a number line
and then
plus
positive or
line.
negative. Yeah, but it helps us in graphing too. Yeah, it's typically how the book usually tell you, that's all you have to do. But it also helps if you see the graph, because it gives you more information about what's going on. Especially in calculus, when we deal with slopes, rates of change. Because if you look at this equation here, this one is positive, this one's odd, even odd, but the whole function is odd because, I mean, it's a decreasing function everywhere. It's a decreasing function. From negative infinity to two, it's a decreasing function. From two to negative 2 to 2, it's decreasing. And from 2 to infinity, it's decreasing. So this is a completely decreasing function from everywhere.
So then would you say, as you go to positive infinity, you go to negative?
Well, yeah, in this case, in the left side, from the first interval, as we go to negative 2, it goes to negative infinity. It always goes to negative infinity because of that, what you said. But this one goes to 0 because it's on top of the x-axis of the horizontal asymptote. But yes, that's great, excellent observation. Normally, if there's a decreasing function, it would all go to negative infinity. But this one, the farthest it can go is 0 because it's got an asymptote. Let's see where we are now. We just did both of these. We have real zeros, and then we'll talk about one-to-one functions. We're moving along pretty good pace. Because we'll finish this next class. We'll do logarithms after the break, and then we jump into trigonometry. If we didn't move our spring break because of the high school, it would have ended perfectly. We'd done algebra first. When we came back from spring break, we had trigonometry. And these are all the trig functions that we're going to work on. And then we're going to look at polar coordinates, hyperbolic, and these are the functions, the rational functions. And then if we have time, we'll look at all these, which we should have time. We're well ahead of the game.